Alrighty, I'm going to show you how to use a scale factor to find the missing side lengths of an image shape that is similar to the original. Okay, remember the definition of similar means that they have same angles. The two shapes have the same angles and proportional side lengths. So what we are looking at here is a problem that essentially asks, using the scale factor, find the missing side lengths of the image shape. Okay, so I'm going to give us a scale factor here. Let's say that the scale factor is, I'm going to write, let's see, SF, the scale factor is 2. Let's make the scale factor 2. So my scale factor 2, I'm going to do what's called a dilation. Okay, I'm going to do what's called a dilation. That means I'm going to keep the shapes similar. That means all the side lengths are going to stay proportional. The angles measures are going to stay the same. I'm just going to make the shape bigger or smaller. I'm going to either make it bigger in size, or I'm going to shrink it down. Okay, that's what a dilation is. Okay, so I'm going to do a dilation here using a scale factor of 2. Okay, so I'm going to dilate triangle ABC. Okay, ABC is the original triangle here in this case, and I'm going to use my scale factor to find the missing side lengths. Okay, so first thing what I need to do is I need to identify the corresponding sides of these two triangles here. So I know that 10 is going to correspond with this side here on my larger triangle, because 10 is in between 50 degrees and 60 degrees, and this red circle that I drew there is also between 50 degrees and 60 degrees. So those are going to be corresponding. Okay, 6 corresponds with this missing side here on my larger triangle. That's side EF, and then 8 here corresponds with side length DF. Okay, so here's how I use my scale factor. Okay, I'm going to take my scale factor here, which is 2. I'm going to take my scale factor. I'm going to take my original side length here, and in this case, I'm going to start with 10. I'm going to take 10. I'm going to multiply it by my scale factor, and I get the missing side length. So I just take 10, and I multiply it by my scale factor, which is 2, and I get 20. Okay, so this missing side length here is 20. I'm going to try to write it nice and small. 20 degrees, or sorry, not 20 degrees, just 20 units. Okay. Now, do the same thing with 6. So I'm going to try to find what goes into this blue circle there. So I'm going to take 6, and I'm going to multiply 6 times my scale factor, and I get 12. So this is 12 here. And then finally, I'm going to take 8 and multiply that by my scale factor, which is 2, and I get 16. So this missing side here is 16. Okay, that's how you use the scale factor. Now, scale factors are not always whole numbers. Sometimes they are fractions. Okay. Also, when we do a dilation, that means when we make a shape larger or smaller, sometimes we are shrinking the shape down. We're taking an original shape and we're shrinking it down. Okay, so let's look at another example here, but this time, let's say that triangle DEF is my original shape. So I'm going to write O for original, and I'm going to write, let's say right in there, that's I for image. So DEF is this is my original shape, and it's going to get dilated to become ABC. Okay, so as you can see right off the bat, I can tell that DEF is going to get smaller. It's going to shrink down. Okay, now you need a scale factor to do a dilation. So let me give you the scale factor here. So let's say that the scale factor, so SF, let's say that the scale factor this time is, ready, 1/2. Okay, so my scale factor is 1/2. You do the exact same process that we did before. Okay, I'm going to choose a side length like, let's start with 12 this time, and the corresponding side to 12 on my image shape is going to be right there. So EF corresponds with BC. Okay, here's what I do. I take my original side length, which was 12. I multiply it times my scale factor, which is 1/2. Okay? And if you have trouble multiplying a whole number times a fraction, what you can always do to that whole number is put it over 1, and you can multiply straight across. So 12 times 1 would be 12. 1 times 2 would be 2, so you'd have a fraction of 12 over 2. But I'm going to skip that step, skip writing that down, and just do it in my head. 12 times half, or half of 12, would be 6. So this side here is 6. So sometimes the scale factor actually shrinks the shape down. I hope you notice that, going back to the original that we started with, when the scale factor was a whole number larger than 1, when the scale factor was bigger than 1, what happened to the original shape? The original shape was ABC here. What happened to it? It got bigger. This time, when the scale factor was less than 1, it was a fraction of 1/2, what happened to DEF? It got smaller. Okay, so one more time, when the scale factor is a number bigger than 1, the shape is going to get larger. And when the scale factor is smaller than 1, like a fraction that's less than 1, the shape is going to get smaller. Okay, let's continue finding the missing side lengths here on ABC on our image. So I'm going to take 16. Okay, the corresponding side to 16 is side AC. So DF corresponds with AC. I'm going to find what AC is. So I'm going to take 16, multiply it by my scale factor, which is 1/2. Half of 16, or 16 times 1 over 2, is going to be 8. So this missing side here is 8. Okay, and then finally, 20 corresponds with AB. Okay, 20 corresponds with AB, so 20 times 1/2 is going to be 10. So that missing side length there is going to be 10. There you have it. That's how you use a scale factor to find the missing sides of an image shape.